Hello, welcome to the Day 12 notes on Section 6.6, the remainder and factor theorems. Today we're going to be doing two things in this lesson. The first, we're going to evaluate functions using synthetic substitution, and then the second part is we're going to determine whether a binomial is a factor of a polynomial. Okay, so the way synthetic substitution works is if you are trying to find f of r, so in here that's some number, r, we're going to use synthetic division to divide f of x, the polynomial, by r. Whatever the remainder is, that's the value of f of r. So for example 1, we have f of x equals 3x to the fourth minus 2x cubed plus 5x plus 2. So because I'm trying to find f of 4, the 4 is going to go on the outside of the synthetic division. And then remember, across the top, we're going to put all the coefficients of f of x. And we have to be mindful of missing values of x. So notice here, we don't have an x squared. We have to put that placeholder of 0 in there, and then the rest of the coefficients. Okay, so remember, we draw our line. Going down, we add, or bring down the first coefficient is 3. Now we take 3 and we multiply it by that 4. This number on the outside, remember, always gets multiplied by these bottom numbers. So 4 times 3 is 12. Put that value there. Going down, we add. Negative 2 plus 12 is positive 10. Diagonally we multiply, so this 10 times this 4 on the outside is 40. Add, going down, multiply, add, so 5 plus 160 is 165, and now 4 times 165 is 660, and then going down we add. So our answer is the remainder, so f of 4 equals 662. What I want you to be aware of is that if we had done direct substitution, which we did earlier in this chapter, so if I took this original polynomial and I plugged in 4 everywhere there was an x, so meaning I'd do 3 times 4 to the fourth minus 2 times 4 to the third plus 5 times 4 plus 2, that's called direct substitution, I would have gotten the exact same answer. It's 662. Right, so this is just a different way to substitute in. It's synthetic substitution. All right, let's look at example 2. We have g of x equals 2x to the third minus 6x squared plus x minus 112, and we are finding g of negative 1, so that negative 1 goes on the outside. And I put in all the coefficients of the g of x, so 2, negative 6, 1, and negative 112. There was no missing value of power of x, so I didn't have to have a placeholder. Right, going down, we just bring the 2 down, and now we multiply that 2 by this negative 1 on the outside. So we would get negative 2. Going down, we add. Negative 6 plus negative 2 is negative 8. Multiply that by that negative 1 on the outside, you get positive 8. Going down, we add, you get 9. And then diagonally we multiply, you get negative 9. And going down, we add, it's negative 121. So g of negative 1 equals negative 121. Again, if I was to directly substitute it in, I would get that same answer. Okay, the second part of today's lesson is the factor theorem, and this theorem says that if you have a binomial, x minus r, it is a factor of your polynomial if and only if p of r, so when you plug r into p of x, so notice here we have minus r, if we plug in r, we'll get 0. So let's do an example. Determine whether x minus 3 is a factor of x to the third plus 4x squared minus 15x minus 18, then find the remaining factors if it is. So if x minus 3 is a factor, basically we're trying to see, is this going to give us a value of 0? So the value that goes on the outside is 3. It's the opposite, because if this is x minus r, we're plugging in r. Another way you could think of it is if I had a polynomial and it was, zero product property of x minus 3 and then x plus 2, let's say, equals 0, what would my 0 be? It would be 3 from this one, not negative 3. So you always take the opposite of whatever the factor they give you. So if they said x minus 3, we're going to take 3. If it was x plus 7, we would do a negative 7. All right, let's line up write our coefficients. I have all my values of x, so I don't have to put a placeholder. Again, we bring down the 1. Diagonally, we multiply. So we get 1 times 3 is 3. 4 plus 3 is 7. 7 times 3 is 21. Negative 15 plus 21 is positive 6. 3 times 6 is 18. Negative 18 plus 18 is 0. So right here, because we get a 0, we know that, yes, it is a factor, because our remainder is 0. If we got any other value here at the end, we'd be done with this problem because we'd say, no, it's not a factor. I believe most of our problems, they will be. So you're going to have to keep going. Now, the way we keep going, we've got to find the remaining factors. So remember from long ago in this chapter, these numbers are the coefficients of my answer, and you always start with one power lower than the original polynomial you were dividing. So we were dividing an x to the third. That means this is an x squared, and then plus 7x plus 6. Remainder is 0, so that's why we're able to do this. And now we have to factor this. So no GCF. I'm looking for factors of 6 that add up to 7. They are 6 and 1. Because there's a coefficient of 1 in front of x squared here, I could just throw those two numbers into the parentheses with x. So it's going to be x plus 6 and x plus 1. Those are the remaining factors of that polynomial. So now if I was to write this out in completely factored form, it would be x minus 3, the original factor that they gave me because we decided it was a factor, x plus 6, and x plus 1. And if I was to multiply these three factors together, I would get the original polynomial that we start with. Alright, let's do example number 4. Determine whether x plus 2 is a factor of 3x to the third minus 4x squared minus 17x plus 6. And then if it is, we're going to find the remaining factors. So just like before, if they gave me a factor of x plus 2, I'm going to put a negative 2 inside this little half of a box and then write all our coefficients. There are no missing terms, so I just write them as is. Bring down the 3. Now negative 2 times 3 is negative 6. Negative 4 plus negative 6 is negative 10. Negative 2 times negative 10 is positive 20. Negative 17 plus 20 is 3. Negative 2 times 3 is negative 6, and we get a 0 here, so that means we can continue. So we have to write this as a polynomial, and it would be 3x squared, because we lower the power by 1, minus 10x plus 3. Right, there's no GCF here, so we're going to do a times c, factors of a times c, so factors of 9 that add up to negative 10. Factors of 9 are 1 and 9. Now, if two numbers multiply to be positive, they either both have to be positive or both negative. Because we're adding up to a negative 10, if I made both of those negative, it would add up to negative 10. So those are my two numbers. I'm going to split the middle term in two. So 3x squared minus 1x minus 9x plus 3. Now that I have four terms, I'm going to factor by grouping. What goes into these two? Just an x. And I would be left with 3x minus 1. And now what goes into these two, if I take out a minus, or if there's a minus there, I have to take out a minus, and they have a 3 in common. And now negative 3 times what would be negative 9x, would be 3x, and then minus 1. Anytime you take out a negative here, it's going to switch these two signs inside the parentheses. So we had a minus and a plus. Notice we have a positive and then a minus. So it switches those two signs because you're dividing basically by a negative. And so our remaining factors here are x minus 3, 3x minus 1, and if you just want to write the entire polynomial in factored form, we'd have to throw in that x plus 2, which was originally given to us, or we found out that it was a factor. Okay, example 5 here is the last one that I'm going to do with you guys. We're going to determine whether x minus 1 is a factor of 2x cubed minus 10x plus 8. So setting up my synthetic division, if we're checking if x minus 1 is a factor, I put a positive 1 on the outside, and then the coefficients of the polynomial that we're dividing. And hopefully you guys see that we are missing an x squared term, so you do have to put that placeholder there, otherwise your answer will not be correct. So we have 2, 0, negative 10, and 8. Bring down the 2, it's 2. 2 times 1 is 2. 0 plus 2, going down we add, is 2. Diagonally we multiply, 2 times 1 is 2. Negative 10 plus 2 is negative 8. Multiplying, we get negative 8, and then 8 plus negative 8 is 0, which means that x minus 1 was a factor. So we take these numbers, we write it as a polynomial. It's going to be 2 and then x to the second, because we always lower the power by 1 from the original. We start with a cubic, now we have a squared, plus 2x minus 8. Alright, so we have to factor. First step of factoring is a GCF. This does have a GCF of 2, so we take a 2 out, and you have x squared plus x minus 4. Now, when you factor, it doesn't mean you're done. We have to check if this trinomial inside here, if this one could be factored. So we're going to do factors of a times c, so negative 4, that add up to b, the middle number's coefficient, and that's 1. All right, so factors of negative 4, the first ones are 1 and 4. We would have to make the smaller of the two numbers negative because we want it to add up to be a positive one. Negative 1 plus 4 is not 1, so those don't work. And then the remaining factors of 4, negative 4, 2 and 2, one of those would have to be negative. Negative 2 plus 2 is not 1, which means this trinomial, this x squared plus x minus 4, cannot be factored. So our final answer is 2, and then x squared plus x minus 4. And then if we do want to write it completely factored form, we'd have to include that x minus 1 because it was a factor. Okay, I would like you to try example 6 on your own. You're going to determine whether x plus 3 is a factor of x cubed minus x squared minus 8x plus 12, and then if it is, find the remaining factors. So please pause the video and try example 6 on your own. Alright, so hopefully you should have found that x plus 3 was a factor and then gotten a polynomial that factored into x minus 2 times x minus 2, which you could write that way, or x minus 2 quantity squared. And if you want to write it as a fully factored polynomial, you would tack on that x plus 3 that was also a factor of that polynomial. If you did not get this answer, please make sure to ask in class tomorrow. Thanks for watching. Have a good one.